Hello and welcome to Lesson 10 of Higher Computing Science Database Design and Development. We're continuing implementation, but we're doing something that isn't described here. We're going to do a thing called subqueries. In the last video, I made a number of queries, and one of them was to find the oldest dog age using aggregate functions. Seeing only the age of the oldest dog isn't very useful. In the last video, I said it would probably be better to see the name of the dog, or the breed, or something other than just the number. And we can't do that only using aggregate functions. You may think you could do something like where age is equal to max age, and then we could show the dog name. And if we run this, you'll see that it doesn't work. You cannot have aggregate functions in the where clause, so we can't do this. It is possible in many ways to see the name and breed of this oldest dog, but not using what we've been asked to use at higher level. So you may be wondering, why are we learning it? What are we doing here? If we go to page 106 of the Higher Computing Science course specification, or 103 if you look at the page numbers, it does state that you can use the result of a query. Here you can see we're finding the maximum rating of a hotel, and we use that maximum rating to check if the star rating of all these hotels matches the highest star rating, and we display the resort that that hotel is found in. So this is a query within a query. And this is something that Microsoft Access does allow, but it's not allowed by pretty much every other SQL database management system. If we scroll to the next page, it says a subclause may be used to combine two queries. Using subclauses is beyond the scope of the higher course and will not be assessed. However, it may be useful to understand how the result of a query can be used within another query. And there's an example of the exact same thing that was done on the previous page, where we find the maximum star rating and find the resort name of all hotels that have that maximum star rating. And when you check the courseworks and the past papers, you'll find that you actually are asked to find things or create queries that show you results that can only be done using subclauses or subqueries. So if you're not using Microsoft Access, you're kind of up a creek without a paddle. But fear not, because I'm going to teach you how to do it in this video. We're going to do 3 different queries, and you may notice that all of these involve the use of a single number. For example, this one, it finds the oldest dog. So the oldest dog, the age of the oldest dog is the single number we'll use. Here we're using the youngest dog. And in this one, we're using an average walk time. These are all single numbers. And when it comes to finding the name of the oldest dog, we need to create a query in SQL View. And we're going to find the dog's name, obviously. That comes from the dog table. And it's going to be where the age of this dog, the name of which we're about to find, is equal to, well, effectively the max age. But as you know, we cannot do this. You cannot have aggregate functions within the where clause. But what we can do is, instead of using max age, just do a whole other query that finds the max age. So select max age from dog. So this is a query within a bigger query. And here we'll see the name of the dog, Biscuit. And just to be double sure, we could go to the dog table. Let's sort it by age descending. The 18-year-old is called Biscuit. So that's the first query. Let's save it. The next query is to show the name and phone number for the owner of the youngest dog. Again, we're using a single number here. We'll create a query in SQL View. Another way to approach this is, instead of thinking of what you need to show, and think about that single number that you need to find first. So in this case, it's the youngest age of a dog. We want to select the minimum age from the dog table. And we want to show the name and phone number for the owner of that dog. So we could push this down a bit. Select the name, so the forename and surname, and the telephone number. Let's check the owner table. Forename, surname, phone underscore number. From the owner table, but we're also going to need the dog table, because that's where we get the age from. It's going to be where the age of the dog is equal to the result of this query. We do need to put this in brackets as well. Because we're using the dog table, we'll need to add the join. So it's where the owner ID equals the dog.owner ID. And when we run it, you can see we get lots of results. You might be thinking, that can't be right. There are 38 results in total. If we go to the dog table and let's sort it in ascending order of age, you can see there are lots of dogs that are 1 year old. And if we go to the last 1 year old, you'll see that this is dog number 38. So there are 38 dogs that are 1 year old. Therefore, there should be 38 owners. Some of you may have noticed that there is a problem. There's a little bit of repetition. Mariam Kurbold and Dale Hobach. They've appeared a couple of times. There may be other ones that appear multiple times. If you don't like that, you can fix it by grouping by the owner's forename, surname, and phone number. Group by forename, surname, phone number. So now we're only getting 36 results, and that's because despite there being 38 dogs that are the youngest, they're all equal youngest, some of these are owned by the same person. So there you have a subquery. Let's do another one. Save this first. The final query: show the names of all dogs that have been on a walk that happened later than the average walk time. We create a query in SQL view. We want to show the names of all dogs. So that's going to be the dog name from the dog table where, and this is where we find the walk time, the average walk time. So we're going to also need the walk table. And it's where the walk time of that walk was later, look at this, later than the average walk time. So greater than is how you find a time later, and we select the AVG walk time from the walk table. This subquery again needs to be in brackets. Because we've used two tables, we need to join them. So and where dog ID equals the walk dog ID. Let's run it. There we go. Look at that. There's 5,393 dogs who were walked later than the average walk time. Does that seem reasonable? Well, if we open the walk table, there are 10,000 walks, and you would think that there's going to be a roughly half that were after the average time and roughly half that were before the average time. Obviously, there's a chance it's not exactly half, so 5,400, yeah, that seems pretty reasonable to me. Again, we could reduce this number because we can see that Ralph has appeared a couple of times already. Where'd he go? Ralph and Ralph. So there will be some repetition. We could fix that again. Let's just group by dog name. So now we're only seeing 292. And that seems quite reasonable given that we only have 491 dogs. So let's say 500 dogs. You're going to see about half that plus or minus 10% or so. So this falls within the reasonable number of dogs. We'll save this. And there you have it, how to create subqueries or subclauses. These types of questions do appear in exams and in coursework, so you do need to know it. And the method we saw today was doing it all within one query. So a query that makes use of another query, the result of another query. In the next video, I'll show you the Microsoft Access version where you save a query first and use the results of this query in another query. In the meantime, I hope you've enjoyed this one, and I'll see you in the next one.